Okay, hello. Uh, I'll be starting soon. We'll wait for uh, more people to join in. Oh, we'll start at 4:35. All right. I guess I'll start the stream now. All right. So hello and welcome to my Unity's beginner live coding session. I'm Sarkis. I'm a computer science student at Area 1 University, Dubai. I'm also the game dev director at Tech Club. And this is my GitHub, which I'll be posting this project soon after the stream. Hello everybody in chat. Hello Professor Talal. So what is Unity? I hope we all know what video games are. So Unity is a video game engine developed by Unity Technology. It has multi-platform support. You can have it to build games for mobile, PC, console, etc. And it has also VR support. It supports both 2D and 3D games, not just 3D. And it's used for things other than game development. It can be used for animation, architecture, and engineering. In fact, there's a 7-minute long short film on Unity's YouTube channel. You can give it a watch after this, which is like shocking how good like this engine is for rendering animation. Next, why use Unity? Well, Unity is easy to learn and start out with. It's one of the most beginner-friendly engines. It has cross-platform support. As I said before, mobile, desktop, WebGL, console, VR devices. It is being used by indie Unity developers, AAA studios, and anything between. You can see big studios using them, independent developers, one-man teams, and sometimes beginners, hobbyists, and amateurs using them for fun and learning. It uses C# as a scripting language, which is a better Java. It is a multi-purpose engine, as I said earlier. You can use it for architecture and so on, and has very useful tools. Unity, being arguably the most popular game engine, has a lot of tools in its arsenal. And today's stream, I will not be going over the tools you can use in them, but uh, just know that Unity has a bunch of tools developed for it, which can ease your game development journey. So let's get started. So let's begin with the Unity scene. Scene is a collection of game objects where you can manipulate and move around objects and content in the game. A game can have one or more scenes. So let's move over to Unity. Right here. So this is the scene where you can move around in it and check out the objects. For now, this is an empty scene, and all we have is a main camera and the directional lights. Moving on, we have game objects. Game objects are essentially anything that can be in a scene. Game objects have components that give them properties. All game objects have a common component, which is a transform. Transform being the position, rotation, and the scale of the object. Basically anything for its visuals and placement. So let's create a game object here. So to create your first game object, you go to game object, create empty. Here, as you can see, we have an empty game object. It does nothing. Only thing it has is its position, which you can move here. Rotation, see it rotating on the x-axis. And its scale, which I can't really demonstrate right now because it's an empty game object. Let's delete that and create a cube object. You can see, let's reset it to the origin, and here we have a cube object at the origin of your scene. Origin being the 0, 0, 0 position. So here we can move the cube up and down, left and right on the three axes, or three-dimensional axes. You can also change it to 2D and move it around two-dimensional position. For now, we'll stick to 3D. They're very similar. Yeah. And I'll show you the scale. Here you can manipulate the scale of an object to your liking. All right. So, object hierarchy. So basically, the small window you see on the right here is the hierarchy. Hierarchy is the list of objects in the scene. As the name suggests, it's in hierarchy. Each object can be a parent, child, or both. And one thing you need to know is that children objects inherit their parents' transform. They don't inherit the actual transform, but their transform becomes relative to their parents' position. And you can rearrange the orders of the objects in the hierarchy. That doesn't change much, but in some cases that becomes relevant. For now, let's just ignore it. So here we'll create a bunch of objects. I want to create a sphere, right? And place it in the origin. Here you can see the sphere. It's overlapping with the cube. And I drag the sphere on top of the cube here. I hope it's visible. Right? And now the sphere has become a child object. So let's move it up here so it's visible. Right, now as we move the cube here, we see that the child sphere is moving along with it. It shares its scale and rotation. And let's change the scale here to 2, right? Twice as big. But as you can see, notice the scale on the sphere remains 1, 1, 1. It's relative to its parent objects. Children can also have children of themselves. We can create a cylinder, and it inherits its parents, and its parents' transform. Let's delete this for now and go back to the presentation. Let's talk about components. So on the right here, we have the camera object and its components. Below the transform, you have the camera component, and the camera basically has its own fields and values and variables. This allows you to tweak how the camera works and so on. We don't have to worry about the details of what the camera does, but know that each component gives an object behavior and changes the way it acts. But for this stream, we'll be creating our own component using mono behavior. What mono behavior is that it is everything that you can attach to an object or a component. So we'll go back to Unity here and create our first script. Right click on the project asset menu, click on create, and click C# script. We'll name it anything. For now, we'll name it our first script. First script. All right. Open it up in our code editor. I'm using Visual Studio Code. And here we'll start. I know coding might be intimidating for some of you, but I'll keep it as simple as possible. For now, we have our class, our first script, which is the name of our script, inheriting from mono behavior. Sarkis, okay, I will try to increase. I'll bring the mic closer. Setting. I'll just try to be closer to the mic. Also, thank you for attending. So it inherits from mono behavior. Mono behaviors, as I explained earlier, are everything that can attach to an object, similar to the camera properties. Right here, we have the camera has its fields. This is a mono behavior or component, right? I don't want to overcomplicate it. Let's jump back into the script. So here are two things we call functions or methods in C#. We'll ignore this one for now. Here we have the update method. Basically, everything you write in here happens, it is called once per frame. Every single frame, this is called. So let's test out something, right? We know every object has a transform. So let's try to access it through our mono behavior. So we go write something along the lines of this object or this script dot game object. The game object is attached to dot. We'll look for the transform. This gives us the transform object or transform component of the object, which is here. In this case, it's this one right here. And then we'll try to say translate it, which means to move the object using vectors. Now, what vectors are it's a little complicated. If you don't know what vectors are, they're basically these three values, x, y, and z. They're used in math and physics for calculating positions, forces, and such. Most of you should know what they are, and for those who don't know, just assume it's the position of an object here, right? So for the specific syntax of translating something here, it would be writing new vector 3, and this allows us to create a new vector 3 to input it to the translate function here. Let's keep it simple and write this 0, 0, 0. Let's say we want to make it move upwards by 1 every single frame. let's save our script, go back to the game, and attach it to an object right now. Right now, we don't have an object, so I'll create a cube here, place it at the center, and attach our script to the cube by dragging it and dropping it over here. See, our first script is attached to the object. If you're wondering what these other components are, these are used for rendering the object. So the model, this renders it, and this is a collider, basically makes it solid. Let's ignore those for a second and see if our script works. Let's play, and oh, where did our cube go? As you can see, our cube is going really far up high, right? Look at the Y value here, it's going a little too fast, right? Because this is called once per every frame, and we have a lot of frames right now, right? Go click game and stats, play it again. You can see we have 1000 frames per second. In order, most of the time it's going to be less when you're playing an actual game, but in this case our function is being called 1000 times per second, but we want to make it consistent or relative to our time in real world. So how do we modify that? First, we multiply our vector, our new vector, by a value. This value, time delta time, is the time between our frames. Basically, when you multiply something by time delta time, you're essentially making it consistent with a second, right? Instead of this being 1 unit per frame, it's moving up by 1 unit each second. So let me comment this out. This moves our object by 1 unit every frame, right? But if we multiply it by delta time, it moves 1 unit per second. This makes our our thing more consistent with different devices with different frame rates. So always with everything that's relative to time, you'd rather have time no delta time built in. So let's play our game and see what happens. As you can see, our cube is moving a lot slower. It's moving a unit per second, which is excellent. Now we can easily, more consistently control our object's movement. But just moving upwards is a bit boring, right? What if we could control this object? Let's see, right here. Okay, so let's create a variable. So variables are essentially pockets of data or information you can store to edit later or use them later. So right now we want a vector 3, a three-dimensional vector called movement. This will be our movement for the frame. Basically, this gets reset every single time we call the update function, which is every single frame. So this stays in our update. And now we'll write new vector 3. This might be a bit complicated, but for those who don't understand object-oriented programming, but just say we just created a new vector 3, right? We're going to use it now, right? And right now it's just zeros and zeros, right? We want to maybe like move it on the X and Z axis. So let's create two floats. Floats are basically digits or numbers. what's special about them is that they allow you to store decimal places. We'll write x movement, which is x direction movement. That's right, x direction movement. And another one for our z direction, right? So this x and z will allow us to move the object. We can rename objects as well by pressing F2 or double clicking on it. You can write, we'll name this one my objects. Right. And also, any questions so far? You can ask me anytime. All right, so we have our cube, right? We've attached the script to it, and we have the x and z axis, right? So we want to manipulate it using our inputs, the arrow keys on our keyboard. How do we go as far as to do that? Go back to our script, and on the x float, x direction movement, we equal it to input dot get axis horizontal. I know you might have questions as to what input dot get axis is, but don't worry. It's simply the space between vector 3 and the parentheses syntax thing. Oh, no, it's not necessary. It just looks cleaner, in my opinion. He's asking about the space between the thing. You can write however you want. You can have multiple spaces. It's fine. I prefer having the space because it's cleaner to read. Okay, getting back to the movement. So input.getAxis horizontal is a way of us fetching if the arrow keys have been pressed, right? So this tells us if the left or right keys have been pressed. It gives us a value of numbers. So it gives us -1 if we pressed left and +1 if we pressed right. Okay, this is for our x value. And it's very similar for the z. What we have to do is write input get axis vertical. This basically returns the value for up and down. And I'll copy and paste the comments accordingly. It tells us if the up or down keys have been pressed. It gives us -1 if we pressed down and +1 if we pressed up. So how do we use these values? Now that we have them, how do we use it? Easy. We fetch the value and place it in our movement vector. So we take the x direction movement and place it in the x value of the vector, which is the first one. And then we take the z value here and paste it here at the z position of the vector. So far, I hope it's easy. And now we take this movement and translate our object by that amount. So we replace this new vector 3 we're creating and place movement in here, right? We go back to Unity and play. Let's see what happens. Will it work? As you can see, our cube is moving, but it's a little slow. And would it be nice if we could control our speed here? So let's go back and try it. Open up our script and go up here. We'll create a public variable. What public variable is that, you remember those fields we could see in the camera? We're gonna create a field like this for our speed. Go to back to our script, write public, meaning we can access it from our editor, from the inspector window. Float speed, we'll name it speed. So it's a public variable that is of type float, meaning it's a number that can have decimal places, called speed. And we'll put it as 1 for now, right? We go back to our scene and click here. As you can see, we have our speed field thing, and we can assign it to anything we want. Let's play our game. Test it out normally now. Wait, forgot one thing. We have to multiply our movement by speed here. You can see it's movement multiplied by speed multiplied by delta time. So we go back to our game and play. So far it's the same, right? Because we're multiplied it by 1. We can also we can then increase the speed to say 5, right? It's a lot faster now. It's moving by 5 units per second in each direction we're pressing. You can press up only, down, right, and left. Okay, so I'll comment this out and say this is our speed variable, and this moves our object by movement. This movement every frame. It moves it per second. We're no longer moving it up per frame, we're moving it according to our input. So this is it, and this is how you code your first script, inputting movement and moving an object on the scene. Any questions? If there are any questions, I could like explain or change a thing about the script if you're curious. All right, so this is it for my short stream about Unity, and let's go back to the presentation. So lastly, can you add spacebar jump using the Z-axis? Okay, you could go back here if you have a question. Can we have different speeds for different movement axes? All right, okay, I'll answer both of these. First one, I'll answer, can you add spacebar jump to the Z-axis? Yes, we can. In fact, it's a little bit more complicated. Now, let's see, we could have float jump equal to, say, 1, right? And we can move it up by jump each frame, but this does not change the fact that we're pressing spacebar. So how do we do it, right? Spacebar is not an axis like vertical and horizontal, so it works with a button press. What do we do here is that we first of all set it to 0 and check if input dot get button, check if we have pressed the spacebar button this frame, space, and if we have, we set jump to say 1 and put it here. So we go back and try it. We have an error. Space is not a setup. All right. I may have used the wrong code here. It's supposed to be dot get key dot key code dot space. Basically, we're asking here if we've pressed the key space. The syntax is a bit awkward to get used to, but don't worry about it. All right. So clear that error and let's try it again. Press space, hold space, and you can see it slowly going up. But we don't have gravity, so it doesn't go down. Right now, I will not be talking about how to code gravity. It's a little bit more complicated. We'll be getting into like realms of physics and stuff. I want to keep it simple for this stream. But we could cheat a little bit and say else. If we are not pressing the spacebar button, we could have it just go down instead. Place negative here. So right here. If we are not holding the space key, we move up. Else we move down. You need to use input.get key down space. Let's get key down is framed. No, I think it has to be get key because we're checking every single frame. Are we gonna have more sessions in the future? Hopefully, yeah. I'll try my best to have more sessions. Get key will detect a key held and not a key press. Yeah, that's true. Right now we're using a key hold, not press, because we don't have jumping functionality. We're just moving it up on the frames we're holding it down, right? Else we move down. We don't really have a jump, but that's true. If you do have a jumping functionality, you just want to jump once when you press the spacebar. So you would use get key down, right? So let's go back and let's change the camera. Actually, you know we could change. Did you know we could change how the camera looks? Let's rotate it and bring it down so you can easily see our object jumping. Right. As you can see, it's falling down, but as soon as we press spacebar, it starts to go up. Yeah, not as interesting, but that's how we'll do it for now. As for Bobber's question, can we have different speeds for different movement axes? We can. Right? We could have the X speed, and we could have the Z speed. In fact, we could even have one for our Y, which is our jump. How we do it is we take this value, multiply it on each individual axis value. So on the X movement, we multiply it by X speed. By Z movement, we multiply by Z speed. And the jump here, we multiply it by Y speed. Right? And we remove speed here since we removed it in our code. Right? Go back to Unity and open our object. So let's play and see what happens. Let's put Y speed to 0 right now because we don't want it to move. We just test out the X and Z movement. Movement so far is normal and slow at 1 speed. Say let's make our X 5, and as you can see, we're moving faster on the X axis as compared to the Z axis. We can make this even faster. Let's put Z axis at 10. All of a sudden, Z axis moves faster than X axis. And this is it. Any questions? I hope everything was clear. Very cool. Thank you. have a question for you guys. Why do Java developers wear glasses? All clear, Professor. You're welcome. You're welcome, guys. Yeah, answer my question. Why do Java developers wear glasses? Take your time. I'll let you guys guess. Okay, never mind. I'll because their code isn't clear. Nope. Because they can't see sharp. They can't see sharp. Get it? It's not my joke. I'm sorry. All right. Lastly, any final questions before I end the session? I stole the joke from our tech club president. All right, no questions. I'll wait for a few minutes if anyone's typing a question. Anyway, thank you guys for attending the stream. I'll stay here for like 5 more minutes in case anyone has a question or something came up. Let's go to 3D Turing machine in Unity. Give that a few more sessions. I think we're skipping a few steps here. Bless, I can make game better than EA now. That is true. Seems like we don't have any questions or anything, so I guess thank you for attending once again, and I'll be ending the stream. Thank you guys.